Say, we need to make a point.
Alright, good morning everybody. This is lesson 17.3, dot plots and data distribution. It should be page 497 in your math book. And the TEK for this is interpret numeric data summarized in dot plots. And our central question today is, how can you summarize and display numeric data? So it starts out and says, how much does a typical cat weigh is an example of a statistical question. A statistical question is a question that has many different or variable answers. So a variable means a different outcome. So if you're playing checkers with your grandpa and the first game it takes you 6 moves to beat him, it doesn't necessarily mean that it will always take you 6 moves. It might take you 50 the next game. So let's look at these first couple questions and decide whether each of these situations below could yield a variable data, which basically means produce a variable data. So number 1 says, your sister wants to know the typical weight of an adult cat. Well, not all adult cats are going to weigh the exact same. So for instance, you might have one adult cat that weighs 10 pounds and another adult cat that weighs 15 pounds. So this is a variable example. Number 2, you want to know how tall your friend is. So this isn't talking about all your buddies, this is talking about one friend in particular. So if we went up to him and decided to measure him, he's going to be one height. He might be 6 foot 1 inch, but he's not going to be 6 foot 1 inch, 6 foot 2 inch, 6 foot 3. It's just going to be one particular height. So this is not a variable. Alright, so what I want you guys to do is pause the video here in just a second and answer 3, 4, and 5 on your own, and we will get back to it. Alright, so number 3 says, you want to know how far your house is from the school. Well, your house isn't going to move, so you're going to be the same distance away every day, unless you and your family do decide to move. A car owner wants to know how much money people usually pay for a new tire. Well, depending on where you go, depends on how much you're going to pay, so that is a variable. And number 5, how many students were in line for lunch at the cafeteria today at 12:30? This is not a variable because those students were there already. Okay, we're going to skip part B and the reflection, so go ahead and turn your page over to 498, making a dot plot. Okay, so just like we mentioned earlier, there is the QR code, so if you are having a little bit more trouble with this, please scan that and get a little bit of help. So we're going to talk about a dot plot, and a dot plot is a visual display in which each piece of data is represented by a dot above a number line. A dot plot shows the frequency of each data value. So frequency means how many times something's occurring. So example 1 says, a baseball team manager records the number of runs scored by the team in each game for several weeks. Use the data to make a dot plot. So we have all of our data here, and it says to make the number line. It's already done for us, and the data values range from 0 to 11. So that's where all that is. So what they did is they just took whatever number that they had, that's how many runs they scored, and they put it above the number line. So 1 would go right here, 3, just like a bar graph, but without an actual bar or a y-axis. You're just putting the dots all the way up. So that's what that is. And then let's look at the reflect questions. How many games did the team play during the season? How can you tell from looking at the dot plot? Okay, pause the video and answer question number. Okay, so number 2, it asks how many games they played during the season, and it is 19. I know that because I counted up all the dots, and each dot represented one game. So if there are 19 dots, they played 19 total games. Pause the video and answer question number 3. So question 3 asks, how many games did the team score 2 runs or fewer, and how do you know? They scored fewer than 2 runs in 10 games, and I know this because I counted the numbers from 2 and less, and when I counted all those up, I got 10. So that is how many games they scored less than 2 runs. Now we're moving on to your turn right here. This is number 4, so go ahead and pause the video and work out this question. Okay, so I made my dot plot, and this is what it should look like. So I just took the data that it gave me and put the frequency of each one above the number line. So the question's asked, tell how many games the team played and identify the data value with the greatest frequency. So the team played 14 games, and we know that just by counting up the number of dots that we have, and they scored 4 runs more times in those 14 games than any other amount of runs. So the greatest frequency on this dot plot is 4. Alright, so now we're on page 499, interpreting a dot plot. So what I want you guys to do is go ahead and read through all this, especially the highlighted word outlier. So go ahead and pause the video now and read over that. Okay, so I'm looking at the last paragraph here under interpreting a dot plot, and it says you can describe the center and shape of a data set in terms of peaks, clusters, or symmetry. Symmetric distribution has approximately the same number of data values on either side of the center. So let's look at example 2. I want to talk about those 3 words, so let's go ahead and underline those real quick. We've got peaks, clusters, and symmetry. And we'll talk about how to determine what all of our dot plots represent. So A says the data values are spread out from 3 to 7 with no outliers. So outliers would be things that are way out, greater than or less than, and I don't see either of those. So all of our stuff is in a cluster, which is one of the words we talked about a second ago. So everything is clustered together. It does form a peak, because if you look at it, the 5 is the peak, it's the very top of it. And if I were to cut this in half, it would be pretty symmetrical because they'd be almost the exact same, not perfectly, but pretty close to being the exact same on both sides. Okay, so looking at B, it says the data values are spread out from 1 to 9. The data value 1 appears to be an outlier. So if we look at this, we've got a nice little cluster over here, but then we've got this 1 way out here. It's kind of not really affecting the rest of our data. This would really change up the mean or the average of our data. So we call this an outlier. So I'm going to go ahead and write that out here, just to kind of be aware of that. And now let's discuss how we'd read this. We've got a little cluster except for the outlier. We do have a peak that is our highest one, and that's at the 9, because if you look at our dot plot, the 9 is higher than everything else. And it's not really symmetrical, because if I were to cut it in half, we would have the right side. These two would be much greater, much taller than the other ones. So this one's a little bit different than A up top here, but you can see some of the different labels and ways that we categorize these types of dot plots. Okay guys, so right next to example 2, there's a little section called My Notes, and I made a little cheat sheet for you, just some notes that I thought would be beneficial in case you got confused. So we've got our peak, which is just the highest point of any data. That's where it peaks out at. We've got a cluster, which means that there's no outliers. All of our data is very close together. And then symmetry or symmetrical means that if we cut the data in half, it would be the same on both sides. So go ahead and pause the video and copy that down just so you'll have it as a reference. Okay, number 5 says, your turn. Describe the spread center and shape of the data distribution from example 1. So go ahead and pause the video and answer that, please, and then we'll discuss that in class tomorrow. Alright guys, now we are on page 500, finding measures from a dot plot. So let's see here. It says we're going to find the mean, median, and range of the data. So this is the exact same information that we had on example 1 about the baseball team and how many runs they scored over 19 games. So step 1 says to find the mean, we need to find the sum of data values and divide by the number of data values. So basically what we've done is we found the sum, we added up all the number of runs scored, and we found they scored 61 runs. That's our sum. And then we're going to divide it by 19, which is the number of data values that we have. So when we divide 61 by 19, we get 3.2, which is the mean or the average of how many runs scored by this team. Step 2 says to find the median. So just a reminder, the median is the middle number with all of our data. So the first thing that I would suggest is to list out all of the numbers from least to greatest. Once you've listed all of them out, you're going to go find what exactly the middle one is. So the tricky part here is that we have multiples of each number. So we'd have to list out the number of games that they scored 2 runs in every time. So we'd find that the median is 2. You guys should know how to do this. We've worked on it the last couple of days, so hopefully that is just a little refresher for you. And step 3 is to find the range. And in order to do that, we're going to take our greatest value and we're going to subtract our least value from it. So they scored 11 runs, which is the most that they scored in a game. So that would be our greatest value, and our least value would be 0 because that again they scored 0 in. So 11 minus 0 is 11. So the range for example 3 is 11. Alright, down here on part B, we're still talking about example 3 in the same data, but it's talking about the outlier, which is 11. Because if we look back at our box plot, we have a nice little cluster over here, but then 11's our outlier kind of off to the side, and it's really throwing our data off. So what I want you to do is pause the video really quickly and read through the rest of this page. So in part B, it really does talk about how the outlier may affect our data. So what we've done is we've taken out the 11, which was the outlier, and we ended up with 50. And then since we got rid of the 11, we also have to reduce our data value to 18 because we're taking one out. So when we do find the mean by dividing 50 by 18, we get 2.8. And so without the outlier, our mean becomes 2.8, which is a little bit closer to the median from the original problem. Now, when we did the median without the outlier, we still got 2, so it's still telling us that in the middle would have been 2, but our mean and our median are now a little bit closer than they would have been had we still had the outlier. So it's just a different way to think about it, and it's kind of showing you that an outlier does affect the data. Sometimes when you have a very low or very high number, it completely changes the way that you're looking at information. Okay, so the last thing I want you to do is go to the next page, page 501, and answer question number 6 for your turn. And again, we will discuss this one in class. All right, guys, good luck, and we'll see you tomorrow.